G'day guys, Joe here and Mike again. We're going to help you bridge the knowledge and skills gap. That's what the idea of all of our videos are about. So I'm not ashamed to admit it, but I have lots and lots of tools and tech in my workshop, and I forget what's at my disposal. And Joe and I were just talking about this, and I want to sort of share this with you guys. That we all have lots of some of the things we're going to cover here. People know and use on a regular basis. Some other things, some of you don't. And the idea behind all of these little videos is going to be trying to get you guys to have a think outside the square, think about things that you might not always do. For me, it's great because I love it because it's a bit of a refresher course for me, and I hope you enjoy it as well along those lines. Some of you might use this stuff all the time, some of you may not. Some of you might be first, second, third years that have never seen anything like this before. I hope you enjoy what we're about to do, and thanks for the positive feedback so far. Joe, you got anything to add to that?
I believe that there will be people in our trade that could use these snippets of little information and the skills that we're presenting to you. It doesn't mean that we know it all. It doesn't mean that we are experts in it. We're just sharing what we know, and I hope you'll find it useful.
All right, we're going to get started. Okay guys, tonight we're going to be talking about relays. What is an electrical relay? We know that a relay is an electrically operated switch, and here we have some examples of them, and we're going to go a little bit deeper and have a look at what's going on. Actually, we all know what they do. Oh, well, if you don't know what they do, we'll explain that, but we're going to go into some of the intricacies and the internals of a relay.
So these are just some examples of the relays you would have seen, you would have replaced them. And most of the time, we refer to them by the size and the number of pins or the terminals that comes out of each relay. So they all do similar work, but there is differences between them. And if we can start with a very basic relay, what's inside, if you had a chance to open it up, you would have seen there are two things inside the relay. It's not one component. In fact, it's healthy if you think of the relay as a system. Every time we use the word system, it means many components working together towards one goal, achieving one thing. So looking at this relay in front of us, what we have is this winding here. It's a coil of wire, and inside of that wire, you can pick it up and show what we're talking about. Inside of that wire coil, we've got iron core, and we know that if we apply voltage or electricity to that coil with the iron core in the middle, we're creating electromagnet. Is that correct?
Yep, and that's going to pull these contacts together.
Right, so there we go. You already learned the two parts of it. So there are contacts which are totally separate from the solenoid, and there's a solenoid which simply turns that electromagnet in action, and that electromagnet attracts the component that moves, and that's the component that you hear, and it's making the noise.
Okay guys, some of you may have this. This is a little relay tester. So I'm going to plug in that open relay that you've just been looking at, and then press the test. You'll see the relay operation here. So I don't know if you should be able to see that. You can see the contact being made inside that relay. Now, all these other ones, these other pin designs, are for different shaped and different pin design relays. So if you have a look on the table over there, we grab one of those and we'll try one of those as well. Okay, so we'll grab one of these other relays, nice and easy, closest one. And then we just plug that into there. There we go. And I'll test. And what I didn't note on the last one, I don't know if you can hear that with my mic. You can hear the clicking of that relay. Now with this little tester, you select whether it's 4 or 5 pin, and it goes through and does a check. But what this doesn't check is it checks the relay operation, the operation of the low voltage circuit, but it won't test the operation of the current flowing across the high voltage contacts.
Okay, so the operation of the solenoid is that there's two circuits inside. We're using a 12 volts to trigger the solenoid. 12 volts, but very, very low current, low amps, and all that does, it creates electromagnetic field. Electromagnetic field pulls the two contacts together. Those two contacts carry much, much higher load. The load meaning much higher current to feed the circuit that we really want to switch on. So at the moment, the little iron core and the solenoid is being switched by anything that's inside the cabin. The driver, that any of the controls that the driver has, those switches, think of them as the tiny micro switch that inside the car the driver turns it on. When I turn that switch on, I have just created electromagnetic field in there, and immediately you hear the clicking of the solenoid. Now it's the real work that's being done by the two contacts. Those two contacts carry the current to whatever we wish to operate. That component that we wish to operate, we'll call it as a load, because it's electrical load. It uses the electricity to do the work. And when it's doing the work, it's loaded. So the solenoid's job is to use a small current to trigger the two contacts of the larger current.
Yeah, so when you're looking at the wiring of this, you're going to see two very little wires, very micro wires, fine wires that might be going somewhere inside the cabin, to two larger wires which are going to be carrying your load. So the other thing, Joe, I was going to ask is, so relays typically would fail. Some people might not know this, but there's actually, if you look at this one, I'll bring it over to the camera, there's a little spring in the back here, and that spring could fail, which could then mean that the contacts would stay closed all the time, or the contacts could stay fused closed. And that would mean that your device would operate and stay operating all the time. So, but yeah, that's
that's a good point you're making, Mike, because that tester that we just used earlier on, it doesn't really tell you whether it's capable of doing the work. All it does, it shows you by light that the contact is being made, and you hear it that it has been made, but we don't know whether it can carry that current or not.
Okay, so typical relay applications are going to be an ignition relay, a starter motor relay, a fuel pump relay, light relay, AC clutch relay or HVAC relay, or a horn relay. So most of us, when we might suspect that there's a relay issue, we'll go to Swapnostics, so we'll swap a relay, but what's really important at that point is to make sure that your relay configuration that you're swapping it with is exactly the same, because we have 4 wires going into these relays that we're talking about, pins 85 and 86, which are our small control current, which turns the relay on and off, and obviously pins 30 and 87, which are our actual connection that we want to do to operate the device. So you're either going to be swapping those, or you're going to manually power those. So some of us, and I've done this many a time, is use a split pin or a jumper wire. The problem there is to bridge, you need to understand which wires you're going to connect together, which are 30 and 87, to operate the device. So that might be an AC compressor clutch. You might feel the relay click, but you suspect that the relay may not be making contact because the clutch isn't working. So we want to manually activate the AC clutch. So we'll get a big piece of wire or a split pin, put it between terminals 30 and 87 and operate the clutch. The issue there is if the clutch has a dead short in it, you will melt your wires, you will burn your fingers because you're trying to pull out the split pin and it'll be red hot. So a couple of things to bear in mind there is you need to understand the wiring and your pin layout, and also the reference to terminal 30 or pin 30 here is a standard reference to battery positive. So you know that 30 is always going to be battery positive, or nearly always going to be battery positive. It's the same as your terminal 30 on your scan tool, just as a little bit of reference. Okay, guys, off the back of that, me talking about testing, you really need to have a look at the wiring diagrams that are on the side of the relay, and you need to understand what pin is doing what. So some 5-pin relays will connect terminals 87 and 87A, so they will create a bridge, so they won't necessarily, it will take terminal 30 and connect it to 87 1 minute, and then the next one it'll take it to 87A, so it'll sort of act like a gate going between the two. Others will, when you power them up, it will power up both 87 and 87A, and some of them will pull things to ground. So you may not always be seeing terminal 30 there as a power source. You might be seeing something else that's a ground. So there are normally open, normally closed, and lots of different styles of relays, but they all essentially do the same thing. Their essential operation is to be a remote controlled switch from a set of smaller wires that are controlled by micro switches somewhere inside the cabin.
Just as Mike was saying that the different relays have different fuses, different pins with the different functions, the relays are also rated by their capacity to carry current, same as the fuses are. Although the fuses are the same shape, they carry different rating, different amps, so are the relays. When you do order a new relay or swapping them around, be careful, be aware of the rating of the relay.
Okay, so Joe, I'm gonna ask you a question. I've done my little test here. I used my split pin or my little jumper wire. I bypassed the relay. My AC clutch is now working. I've got beautiful cold air inside the car.
Yeah.
I know I don't have an air conditioning problem. I've got a relay problem.
Yep.
So how do I test to make sure, other than swapping it with another relay? So it's a real world scenario. I don't have any other relays.
Yeah.
Every other relay in the box is completely different.
Yeah.
How do I don't want to buy a relay.
Yeah, true.
I don't want to just throw parts at it.
So
I want to test the actual relay.
So we want professionally to test it and make a conclusion before we replace it and throwing any parts to it.
Yes.
Makes perfect sense.
How do I do it?
You might have to invest in a kit like this.
Okay.
So,
So this is a Blue Point one that we've got here is a deluxe relay test kit.
okay, and in this test kit, we're actually having a components that sit instead of the relay. So you pull the relay out,
Yeah.
You pull the relay out,
Yep.
and you place it on top of it.
Yep.
Now you're placing the whole thing back in its place. It will function exactly as it's meant to. You will hear it clicking, you will do that. But you do have extra pins in here. Is it on both sides? Or
No, just on the front side.
Or some of them are on both sides,
okay,
like
yep,
this.
yep.
Now these extra pins are really these pins that we have access
they're
to.
piggyback. Oh yeah, there you go. Look at that on the front.
Yeah.
We've got 86, 30, 87, 87A. This is a 4-post. 87A doesn't exist. And 85.
There
Great.
we go.
So, but then could we then now scope these?
Well, scope, it may be
Too much?
or overdone. We could use a voltmeter. And the voltmeter is what we are testing the flow of the volts through it in operation. Now, we will actually be performing that, and that is the voltage drop, because with voltmeter can test potential difference of what is available on one leg of that meter cable compared to what comes out on the other leg of that cable. But that's an open voltage. That is the same as we put the voltmeter across the battery terminal and we say we've got 12.7 volts in it. That's only potential. That is like saying, I've got the voltage, the circuit should work. Or would it make sense if the customer says, I filled the tank full with petrol, my car, and I should be able to travel. The car should be able to start and run and go to Melbourne all on one tank full of petrol. It doesn't mean anything. We actually need to do that test in its state of operation. In other words, loaded.
Okay, guys, so what we're going to do now is a real-world testing scenario. We have our Mazda here. We're going to test the headlight relay. So this is a good example of where you have a relay. There's no diagram. I don't know if you can see. There's no diagram on here. Visually, we can see with this, visually inspecting the relay, I can tell you, and this is how you can tell, the two smaller terminals here are our control from our stalk inside the car. The two larger terminals are going to bring power to the headlights. Now, this is the jump box, the piggyback, and you'll see on the numbers here, we have no terminal 30, no 87, no standardization whatsoever, other than 1, 2, 3, 5, and 4 is a blanked out one on this one. So what we're going to do is we're going to piggyback these together, and I'll shove in, and then we'll plug this in, and we'll use our voltmeter to identify what terminal is what. Now, this one's lucky enough that we've got they're either side of the relay. So I'll turn on our voltmeter, Just basically, of course, always test your voltmeter. And then we're going to have a look around here. So on this side of the relay, we have 12 volts, same as our battery. 12 volts on the other side, and then on the other terminal, on the other side of the relay, we have nothing on that one. And then we have our battery voltage, 12.39, exactly 12.4 volts on the other side. So we know, Joe, you can probably explain this a bit better than me, that these two terminals on this side are our control because we're getting voltage through the windings. On the
Exactly,
relay.
exactly. So one of those pins would receive the 12 volt positive. Because that positive has come into that pin, it has a path to come out of that because it goes through the winding of the solenoid. It comes out on the other pin. So therefore, both of those pins would give us the battery voltage. Confirm.
And this is ground side switch through the stalk.
That's exactly what we'll know. Now that tells us that it's going to be ground switched through the stalk. Absolutely.
Okay, so if I actually left my voltmeter on here and can pull out the relay without pulling out the piggyback, they're tight in there. So we have 12 volts there. Yeah. Now we should have 0 volts on that side. Well,
0.0, yes, no, 0.08. That's absolutely right.
So now,
but you should still have on the other one 12 volts. Check.
0 on 12 volts on that one.
Yeah, and should be 0 on the other one.
I don't know whether you can see that, whether you want to bring that closer. I think you can probably see it, Jeff. I'm pretty sure. So yeah. So what we're doing is, so what happens now is we have. Yeah.
Just take that relay out again, I can very quickly.
Sorry. There you go.
What Mike was saying earlier, by using this, by me bridging these two, what do we expect to see on other headlights?
Turn on.
Why?
Because you're connecting the power to the headlight.
So are we not doing that?
Yep.
So we just verified. Now, I can't bridge this because even if I bridge this is going to be short. Unless we put that relay in it, these two terminals are going to turn that solenoid on. By turning the solenoid on, we're turning the switch on these two. Let's demonstrate.
And you've got to turn the power on.
Yeah, that's fine.
Turn the headlights on. So there's a good example of ground side switching. I think ground side switching tends to it's thrown a lot of my techs over the years. So that little switch inside the stalk is bringing this power, pulling that power down to ground. And that's what's powering and activating this relay.
So tell me now, you had on this side you had 12 volts, on this side you had 12 volts. What should we have now with the light still working?
We'll have whatever the voltage drop is that's activating.
Exactly.
That's activating the coil.
That's a good word, voltage drop. That's exactly what we're going to have. 1196, and on the other side.
Are you on there?
Okay.
Yeah, 9 volts.
So 0.9 volts. So we are doing. So we know that this is the solenoid side. What should we have on this end in here? Remember, we had 12 volts on one end. What should we have on the other leg?
They both be the same. I can do it. I'll do it for you, Joe. So that one is now 11.93. Obviously, we've got the headlights on. Both headlights are on. So 11.92. And on the other one, exactly the same. 11.96. Okay, so Jeff just asked a question, which is really good. So what if you don't have one of these? How are you gonna test what's going on with your relay? So I've got the relay out. Now we know, I can see that you guys probably can't see what I'm seeing, but we've got the two smaller pins. So if I just get my test light or even my voltmeter, you can see the voltmeter. We might use the test light instead. If I go into the little ones, we've got power on that side and we have nothing on that side. So this side we have power going to one of these pins. Now the other side of that pin, I can tell you straight away, just from experience and from knowing what it is, that's going all the way to the stalk in on the steering column, which is going to be pulled to ground when the stalk is on. So right now, if I go to the positive side with my test light, real simple testing, positive side on the test light, if someone goes in, Joe or Jeff, or if someone goes in and just turns that headlight on for me, this light should light up. And that's it, grounding. So we know that, and turn it off again, thank you. And then on the other side, on the larger pin side, we have...
You're on the positive.
I'm on the positive side, there we go. Sorry, I'll go back to my negative side, thank you, Joe. So on one side, we've got nothing on that side, which I can tell you that goes to the headlight. And on the other side, we have what I would normally call like a terminal 30 or a pin 30, which is our power. That's going straight to our battery power, or probably back to our fuse, I would say, somewhere.
Correct.
So on this side, if I decided to go to the positive side and go in here, we don't. Those globes are so big, not going to. They would be going to ground, but they're not enough to actually show anything. So we've got nothing on that side. And if I got my split pin, which is around here somewhere, and as Joe said before, he touched a couple of terminals together. If I went into those two, and you can see there's a few sparks here, and this split pin's getting pretty hot pretty quick. I'm turning I can turn the headlights on and off, and I don't know. Can you see that, Jeff? Yeah. So that's just a little way of understanding what's what, and being able to safely do it with a test light or even with the voltmeter would be exactly the same. Obviously, wherever I see power, the light turns on, so it's a bit easier for me to show you.